I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here are 5 excellent questions based on binomial expansion. We talked about the extended form of this binomial expansion where 1 plus x to the power of n for x, absolute value of x less than 1, and for any value of n can be expanded. Now, based on this expansion, we have 5 test problems for you. I'd like you to pause the video, copy these questions, try them out, and then look into my suggestions. I hope you can see the first 3 questions now. Here are question number 4 and 5. So make a note of these questions, work them out, and then look into my suggestions. Let's begin with their solutions. Question number 1 is, find the quadratic approximation of 1 minus x whole cube divided by 1 plus x to the power of 4. Now, we could write 1 minus x whole cube using the expansion a minus b whole cube as 1 minus 3 times x plus 3x squared minus x cubed, right? So that becomes the expansion of the numerator. That is simple. You could use Pascal's triangle or the binomial theorem to expand this. But how do we figure out the expansion for 1 over 1 plus x to the power of 4? Well, we can treat this as 1 plus x to the power of minus 4. And we'll use the binomial expansion extended form where the value of x is between minus and plus 1, right? So in this, let me put a condition here that absolute value of x is less than 1, right? So for that, we'll have quadratic approximation, right? So you can have quadratic approximation of this provided this value x is between plus and minus 1. Okay. So the expansion for this is, let me give you the general formula that will help you to recall. Okay. So 1 plus x to the power of n is basically equal to 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed plus so on, right? So that infinite series is what we are talking about. Now, since you need quadratic approximation, we'll just take 2 or 3 terms. Since you're dividing, we can take 3 terms, right? So let's see. So 1 plus x to the power of minus 4. Using this expansion of the series, we can write this as 1 plus n is minus 4 this time. So we get minus 4x plus, substituting minus 4 here, we get minus 4 times minus 4 minus 1 over 2 factorial x squared plus minus 4 times minus 4 minus 1 times minus 4 minus 2 over 3 factorial x cubed. Let's simplify this. It can be written as 1 minus 4x. Here we get minus 4 times minus 5. So that gives us minus minus is plus. We get plus 5 times 2, which is 10, right? This goes 2 times, 5 times 2, 10x squared. Now, since we only need quadratic approximation, we'll just terminate to this x squared term, right? Now, we can write down 1 minus x whole cube divided by 1 plus x to the power of 4 as product of 1 minus x whole cube times 1 plus x to the power of minus 4, right? So we already know these two expansions. So what we get here is 1 minus 3x plus 3x squared minus x cubed times this, which is 1 minus 4x plus 10x squared. So I hope that is absolutely clear. Now let's expand. Multiplying by 1, we get all the three terms, which is 1 minus 4x plus 10x squared. Now multiplying by minus 3x, we get minus 3x. Minus 3x times minus 4x is plus 12x squared. And that will give us a higher term, so we'll forget about it. Or you can multiply 3x squared with 1, and you get plus 3x squared. So these are the terms which you get up to the quadratic form. Now let's combine the like terms. We get the constant, which is 1. Powers of x as 1 being 4 and 3, so minus 7x. As far as square is concerned, we get 10, 22, and 3 is 25. So we get plus 25x squared. So that becomes the answer for this particular question. Right? So this is quadratic equivalent is approximately equal to 1 minus 7x plus 25x squared. So I hope the steps are absolutely clear. So we wrote this rational function 1 minus x cubed over 1 plus x to the power of 4 as a product of 1 minus x cubed and 1 plus x to the power of minus 4. Expanded the two and that looked into the terms which had maximum power of x, right? So we got these three terms, and that trinomial is the quadratic approximation of the given rational function. So I hope that makes sense. Let's move on and take the next question now. We are now looking into binomial expansion extended form. Now, which really means that we are now in a position to expand 1 plus x to the power of n, where n could be any real numbers and the absolute value of x should be less than 1, so that we have a converging series, right? That's the reason. So this particular, I'd like you to look into my lecture on this so that you get all the concepts. Based on this, we have a couple of questions which can help you perform better in tests related to this topic. So we'll begin with a very important application, and this is sometimes used for also finding the square roots or estimating the square roots of numbers. The question here is expand square root of 4 plus x as a series of ascending powers of x up to and including the term in x squared, stating the set of values of x for which the expansion is valid. And the second part to this is substitute x equals to 0.1 in both the function and its expansion to calculate the percentage error. So if I substitute 0.1, I get 4.1. So basically, we are trying to find the square root of 4.1. So we'll estimate using the binomial expansion, and then we'll see what is the percentage error, right? Okay, so let's begin by stating that 4 plus x should also be written in 1 plus x form, right? Only then we can expand. So let's recall that 1 plus x to the power of n can be written as 1 plus n times x plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial. You can see a pattern, right? So it's easy to remember this expanded form. I like this. It's an infinite series. Now for this series to converge, absolute value of x should be less than 1. So that gives you the condition, part 2, right? Now in our case, what we have is square root of 4 plus x, correct? So square root of 4 plus x, think like this. It is like 4 plus x to the power of half. So the value of n is a real number. It is not a natural number, right? That is one part. Now that could be written as something like this. We can take 4 common, right? And so we get 1 plus x over 4 to the power of half. And that is equal to square root of 4 is 2. So we can write this as 2 times, and within the brackets we get 1 plus x over 4 to the power of half. Now this portion x over 4 has to be less than 1, the absolute value of this, and then you can actually expand it, correct? So that is how we can really modify this expression and then expand it using the formula given above. Perfect? Okay, so let's do this part now. So now we have to expand 2 times 1 plus x over 4 to the power of half. I'm going to use the formula shown here, and we'll take only first 3 terms. So what we have here is 2 times 1 plus n is half for us, right? So in this case, n is half for us, and the x value really is x over 4, right? Plus, now we have n, which is half for us, so we have half times half minus 1 over 2 factorial times x square, and x is x over 4 whole square, right? Plus so on, correct? Now in this particular case, we'll also write down the restriction here. Restriction is that absolute value of x over 4 has to be less than 1, correct? And that is to say that the absolute value of x is less than 4, correct? So that becomes the restrictions. Okay, let's try to calculate what we have here. So we get this as 2 times 1 plus, that is x over 8, and here we get half minus 1 is minus half, so we get here minus 1 over 8, right? And this is x square over 4 square is 16, plus so on, correct? And we have our condition that absolute value of x is less than 4. Is that correct? Okay. Now, let's try to, that's the expression. We can just multiply these 2 terms, right? So we get 2, 1 plus x over 8 minus x square over 8 times 6, 48, 4, so 128. So we'll just write an approximate value using the first 3 terms, right? So that is the series in the ascending powers of x, right? So the powers of x is increasing up to including the term x squared. So we neglected everything after x squared and stating the set of values of x for which the expansion is valid. It is valid for absolute value of x less than 0.4. Okay. Now part 2. So we've done the first part. Now let's look into part 2. Let me just make some room here to do part 2 now. Substitute 0.1 in both the function and the expansion to calculate percentage error. So if I write 0.1 here, that is to say, in this particular expansion, which is, we can say square root of 4.1 is equal to what? We'll write 0.1 here, right? So it's approximately equal to, as per our formula, we get 2, 1 plus 0.1 over 8 minus 0.1 square over 128. Let's calculate this value using calculator. So what we get here is 1 plus 0.1 divided by 8 minus 0.1 square divided by 128. Right, so we get a value which is, and we'll multiply this by 2, right, times 2. So in decimals, the value is 2 point, let me write this, which is 2.0248 4. Okay. So we have written it to 5 decimal places. So that is the value. Now let us calculate what is square root of 4.1 using the calculator, right? So now we're going to calculate this using the calculator. Square root of 4.1 is equal to, in decimals, it is equals to 2.024845, right? Okay. 0.02484. Okay, so it's, oh my god. So it is almost the same thing. We have to go to 2 more decimal places to get real value. So let me do this calculation, the first one again, since to 5 decimal places it was perfectly matching. Do you see that? How accurate it is? Okay, so let me redo the first part of the calculation. So what we have here is, we'll write 2 within brackets, 1 plus 0.1 divided by 8 minus 0.1 square divided by 128, right, bracket close, equals 2. So I'll add more decimal places now, otherwise we don't really get any error. 84, and after 84 we have 37. Okay. So now we can calculate the percentage error. It does make sense to you. See how accurate this is. So percentage error is what? Percentage error will be the difference of these two values. So difference will be 2.0248437 minus 2.0248456 divided by the actual value, which is this, 2.0248456 times 100, correct? Oh. So let's do this. So what we have here is, I already have this value here in the calculator. We'll do minus 2.0248437 456 equals to. So we have this as, and we'll multiply this by 100. In decimals, it is negative, of course, and it is 1.85 into 10 to the power of minus 4. Do you see that? So it is a very, very small error. In fact, what you notice is up to 4 decimal places, the answer was perfect. Normally, we get accurate answer to 3 decimal places by using these 3 terms, right? So that is the accuracy with which you can get results using binomial expansion, and I hope that helps. And most of the time, if you're estimating without using calculator, that could be pretty good. You could actually do just first 2 terms. That would be good enough to estimate without calculator, right? So I hope that makes sense. Remember that the value of x is such that the series is converging, and that is kind of important to understand. I hope it makes sense. When we say extended part, we are actually expanding the terms, like 1 plus x to the power of n, and that could be expanded as 1 plus n plus n times n minus 1 over 2 factorial nx, I'm sorry, this is x squared, plus n times n minus 1 times n minus 2 over 3 factorial x cubed, plus so on. Now in this expansion, there are a couple of important things to understand, that this series should be converging, and that implies that the value, absolute value of x, should be less than 1, right? Only then we can use this particular series. Now let's look into the question given to us, which is find a and b such that 1 over 1 plus 2x times 1 minus 3x is approximately equals to a plus bx. So we have to write this as a linear function. Do you see that? And the idea is to find the coefficients a and b. So we have two factors here. One is 1 plus 2x. So we can write 1 over 1 plus 2x as 1 plus 2x to the power of minus 1, correct? Now this can be expanded using the formula given here, and so what we get here is 1 plus 2x to the power of minus 1. N is minus 1, right? So instead of x we'll write 2x. What we get here is 1 plus n is minus 1, right? And the value of x in this case will be 2x, right? Plus, we'll use two terms since we just want to find, in fact the third term is also not required since we want only the value a plus bx, right? So x squared terms are not required. So we'll neglect the other term, correct? Okay, so this gives you the value of 1 minus 2x. Right. So that is what it is. Now let's look into the other term, which is 1 over 1 minus 3x. So that should be written as 1 minus 3x to the power of minus 1. And when you expand, you get 1, and this is minus 1. So we get plus minus 1 times minus 3x, correct? The other terms will be neglected, and approximately I can write this as 1 plus 3x. So 1 over 1 minus 3x can be written as 1 plus 3x, correct? And 1 over 1 plus 2x can be written as 1 minus 2x. Now it is important to note that the value of x should be what, right? We have to write the restrictions also in this particular case, right? So let me extend this to say that state values for x, right? So state values for x when this expansion is valid, right? For this example, right? So okay, so these are the two conditions, and we'll just first find what a and b is, and then we'll state the restrictions on x for which whatever we are saying should be valid. Okay, so finally we can write down the rational function 1 plus 2x times 1 minus 3x as equal to 1 minus 2x times 1 plus 3x, correct? So if I expand this, I get 1, and that we get minus 6x squared, right? So multiplying 1 by this, and then with this, and then the second term we get plus 3x, and this we get minus 2x. Okay, so we get this as 1. Okay, and then we have 3x minus 2x as minus x plus x, and minus 6x squared. So that becomes the expansion for this particular case when you multiply. And comparing the terms, since we want to write this approximately as a plus bx, so that means we're just looking into the first two terms, right? So which is when you multiply with this and this, so you get the term, and then you multiply with this, you get those x terms, right? So we get 1 plus x. So the value of a in this particular case is, so we get from here that a is equal to 1 and b is also equal to 1, correct? So that is our answer to this particular question. And now let's talk about restrictions. So clearly, one of the restrictions here is that the value of 2x, absolute value of 2x, should be less than 1. And that gives you the condition that absolute value of x should be less than half, right? The other is that the absolute value of minus 3x, which is 3x, should be less than 1. And that gives you the condition that the absolute value should be less than 1 over 3, right? So within these intervals. And from here, we know that the more restriction is the second value, correct? And therefore, we can say that the absolute value of x is less than 1/3, correct? That really means that x is between plus and minus 1 over 3. Is that clear? So that becomes the restriction for us. So that is the answer for this particular question. I hope it makes sense. We have two related questions in this particular video. You can always pause the video, answer these questions, and then look into my suggestions. The question here is, find a quadratic approximation for the following functions, stating the values of x for which the expansion is valid. 5 minus x over 1 minus x squared and 3 plus x over 2 minus x whole square. So these are the two expressions for you. You can always pause the video, answer the question, and then look into my suggestions. So when we are saying the expansions, what we have here is that 1 plus x to the power of n can be written as 1 plus nx plus n times n minus 1 over 2 factorial x plus n times n minus 1 times n minus 2 over 3 factorial, correct? And so on, correct? So that is one part. And second part is stating the restriction. We know that the absolute value of x should be less than 1 so that this series converges and we could get a value, correct? Now, if absolute value of x is less than 1, then higher powers, this is x squared and this is x cubed, okay. Then the higher powers will be much, much smaller and they can be neglected. So that is the whole idea, right? So keeping that in mind, let us work on this. So we'll work on the first rational expression, which is 5 minus x over 1 minus x squared. Now, we need to find a quadratic approximation. That means we have to write this as a quadratic function. So to do that, let's work on 1 minus x squared first. So 1 minus x squared to the power of minus 1. It could be written like this, right? So we'll use this expansion to expand this term. So 1 minus x squared, n is minus 1 and x actually is minus x squared. So what we get here is 1 plus n is minus 1, right? And the other term is x is minus x squared, correct? And the next term is plus. Now since we need to only go for quadratic approximation, we need not take higher terms. Here we'll have cubic term, correct? Rather much higher. So we are going to neglect this, right? So the next term will be higher. So we'll approximate this to 1 minus and minus becomes plus, so 1 plus x squared. Is that clear to you? So therefore, the term 5 minus x over 1 minus x squared can be written as 5 minus x times 1 plus x squared, correct? Now let's expand this. We get 5 plus 5x squared minus x minus x cubed. Correct? We get this form when we expand this. Since we need to only find the quadratic approximation, we can write this expression as 5 minus x plus 5x squared. So that becomes the quadratic expression, right? Now we need to state the values of x for which the expansion is valid. Now since we expanded this part, so what we have here is that the absolute value of minus x squared should be actually less than 1. And that really means that this is like absolute value, right? So square root of 1. So we can say absolute value of x squared is less than 1. Or this means that the value of x, absolute value of x, is within plus and minus 1 or less than 1, correct? So that becomes the restriction in our case. I hope that makes sense, correct? So steps are clear. I'd like you now to pause the video and answer this second part, which is quite similar to what we just did. Perfect. And then look into my suggestions. Now let's take up solution for the second part, which is 3 plus x over 2 minus x whole square. Now in this, we have to work on 2 minus x whole square, and then we can write this as a quadratic approximation. Okay, so let's work on this part. 1 over 2 minus x whole square can be written as 2 minus x to the power of minus 2. We're going to, now this could be written as, because we want 1 plus something, right? So we could write this as 2 common, right? And over in brackets we get 1 minus x over 2 to the power of minus 2, right? That is how we could write this. And that is equal to 1 over 2 square is 4. And we get 1 plus x over 2 to the power of minus 2. Okay. So that is what we'll try to expand. The formula which we are going to use is 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 over 2 factorial x. Correct. Since we are only in x squared, since we are only interested in quadratic approximation, we'll restrict ourselves to these 3 terms. In fact, we actually need only 2 terms because we are also multiplying by 3 plus x, right? Okay. So we need to approximate what is 1 over 4, 1 plus x over 2 to the power of minus 2. So that is 1 over 4, and we'll expand this part, which is 1 plus n values minus 2, and the x value is x over 2, right? So we'll just take these 2 parts, neglecting the rest. We could take this because 3 is getting multiplied with it, so we'll use this part also. So we have n, which is minus 2, this right one, sorry. So we have minus 2 times minus 2 minus 1 over 2 factorial x square, which is for us x over 2 whole square, correct? Yes, we'll neglect the other terms. That should make sense. Okay. So that is 1 over 4. 2 and 2 cancel. With the negative sign, we get 1 minus x. Now in this case, we have 2 and 2 cancel. Minus 2 is 3. Minus 3. So we get minus 3 x square over 2 square, which is 4. We'll neglect the other terms, right? So that is what. We could now multiply by 1 over 4 and write this as, or shall we keep it outside? Let's keep it outside. Okay. So anyway, you can multiply. So we can write this as 1 over 4 minus x over 4 minus 3 over 4 times 4 is 16x square. That is the approximate value. And now we can write down the expression for what is 3 plus x over 2 minus x whole square equals to, right? It is 3 plus x times all this, which is 1 over 4 minus x over 4 minus 3 over 16x square. Correct? So when you expand, let's multiply by 3 first. So we get 3 over 4 minus 3x over 4 and 9 over 16 x square. Multiplying with x, we can take the first term, which is plus x over 4, plus x over 4, correct? So that's what you get, which is equal to, combining the terms, we have 3 over 4, which is a constant, and then here we have minus 3x and plus x is minus 2x, minus 2x over 4, we'll simplify this, And then we have minus 9 over 16x squared. Or we can write this as 3 over 4 minus half x minus 9 over 16x squared. Correct. So that becomes our quadratic approximation of the given formula. Is that clear to you? Right? Now we have to also mention the values of x for which the expansion is valid. So it is only valid when this value inside the bracket x over 2, this value, right? So x over 2 absolute value should be less than 1. That means absolute value of x is less than 2. So that is the restriction. So the restriction here is that the absolute value of x is less than 2. Is that clear to you? So that is how we are going to answer this particular question. I hope that makes sense. The last question from our practice test is the expansion of a plus bx to the power of minus 3 is approximated as 1 over 27 minus 2x over 27 plus cx squared. Find the value of the constants a, b, and c. You can always pause the video, answer this question, and then look into my suggestions. So let me recall how to go about doing these kinds of expansions. Generally, we are talking about 1 plus x to the power of n, right? Which could be written as 1 plus nx plus n times n minus 1 over 2 factorial times x squared. Now, since we are talking about x squared, we can terminate it here, right? However, in this series, we have a plus bx to the power of minus 3. So it's kind of different, right? So what we can do here is, first step is to write it in this form. So let me rewrite this. So we have a plus bx to the power of minus 3. We could take a common, right? So we get a, and then we get 1 plus b over a x, right? Everything to the power of minus 3. So that gives us 1 over a cube, right? And then we have 1 plus b by a x to the power of minus 3. Is that clear to you? So that is what we get. Now, let us try to expand this using the given formula, and then we can compare the terms to find the value of a, b, and c. So what we have here is 1 over a cube times 1 plus b by a x to the power of minus 3. So if I expand, I get 1 over a cube. Let me put square brackets here. Expansion of this will be 1 plus nx. So 1 plus n is minus 3, right? Minus 3. X is b by ax. Correct. Plus n times n minus 1, that is minus 3 times minus 3 minus 1 over 2 factorial times square of all this. That means b over a x whole square. So that's what you get. Bracket close. So if I open this up, I get 1 over a cube, and here we have minus 3, so it's minus 3 b over a to the power of 4x, and here we have minus 3 times minus 4, and that when you cancel, well, that becomes plus first thing, and minus 4 goes 2 times, and we get 6 here, right? So we get 6 times minus 4 divided by 2 is 2, 2 times 3 is 6, times we have b squared over a times a cube, right? A to the power of 5 rather, a square and 3 cube, right? So x square. So these are the terms which we get. Now, if you want to compare, 1 over a cube is 1 over 27. So first thing is that we can compare and say 1 over a cube is equal to 1 over 27. And that simply means that a is equal to 3. Okay? So we get the value of a as 3. Now, second part is minus 3b over a to the power of 4. So we can say that minus 3b a to the power of 4, which is 3 to the power of 4, x, right, x is there, is equal to 2 over 27. 2 over 27, correct. Now, this is basically minus b by 27 equals to 2 over 27, correct. So that gives you the value of b, right? Since this is negative, that is also negative. Okay, that is also negative. Okay. So we get b as equal to 2. Perfect. So we get value of b as 2. Now c is all this. C is equal to cx square. So c is equals to 6 times b square, which is 2. So 2 square divided by a square. A is 3. 3 square, correct? So that is, we get, you can divide by 1, 3. So we get 2. 2 square is 4. So we get 8 over 3, right? So c is 8 over 3, correct? So we get our solution, and the solution is, in this case, what we get here is that a is equal to 3, b is equal to 2, and c is equals to 8 over 3. Perfect. So these are the 3 values of a, b, and c. Let me highlight them. And that is c, right? So I hope that makes sense. So that was interesting. With this, we come to an end of our series on special cases of binomial expansion. This is extended series where we are saying that the absolute value of x is less than 1. Now in this particular case, you can figure out what could be the restriction on x. That could be an additional exercise for you, right? So b over ax, that should be less than 1. So let's also work on this restriction. Let me write down. So this term b over ax, absolute value should be less than 1, or x should be less than, absolute value of x should be less than a over b. So the absolute value of x should be less than a is 3, b is 2, 3 over 2. So within 1.5, correct? So that becomes the restriction on the value of x for the given condition. Perfect. So these are very important things to consider when we are taking special cases of binomial expansion. So with that, we come to an end of our solution to the 5 questions. I hope it helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.